In this video, I will be talking about the three gas laws, which are Boyle's law, Charles' law, and Gay-Lussac's law. Gay-Lussac's law. Pressure of a given mass of gas varies directly with the Kelvin temperature when the volume remains constant. Again, remember that the temperature must be in Kelvin. Imagine you have a container of 5 liters of gas. If you heat up the gas, its particles will move faster, with more kinetic energy hitting the sides more often, ultimately increasing the pressure. If you cool the gas particles, they will move with less kinetic energy and reduce the pressure. So we know that pressure and temperature are directly proportional when the volume is constant. When pressure goes up, temperature goes up. When pressure goes down, temperature goes down. This law is often used to compare two situations, a before and after. In that case, we can say that P1 over T1 equals to P2 over T2. Graphically, if we put the temperature on the x-axis and pressure on the y-axis, it will look like this. It creates a positive slope. Charles' law. The volume of a given mass of gas is directly proportional to its Kelvin temperature at constant pressure. Notice how the temperature must always be in Kelvin. If you have a container full of gas particles and you heat it up without changing the pressure, the volume will increase. This is because the heated gas particles have movement kinetic energy, so they're hitting the sides more and more, ultimately forcing the volume to increase. So when you increase the temperature, you increase the volume as long as the pressure is constant. This law is used many times to compare one situation to another, like a balloon when you first buy it to when you leave it in the cool room for a night. This can be represented in an equation as V1 over T1 equals to V2 over T2. When you buy a balloon, it's relatively large, but after leaving it in a cool room the next day, you will notice that it gets smaller. If you put the situation into Charles' law, the temperature decreases, so the volume also decreases, which is why the balloon gets smaller. Boyle's law states that at a constant temperature, the pressure and volume of a gas are inversely proportional. Imagine a hard container that measures how many times gas particles collide against the sides. The more particles that collide against the sides, the more the gas pressure. If you make the container smaller, the particles will collide against the sides more often and thus increasing the pressure. If you increase the volume, then the particles will collide against the sides less frequently, reducing the pressure. So we can now draw an equation that relates pressure and volume in one set of circumstances to pressure and volume in another set of circumstances because we know that they're inversely proportional. The equation is P1 times V1 equals to P2 times V2. Now, the unit for pressure will be pascals, PA, and for volume it can be liters, milliliters, etc. So in a graph, Boyle's law looks like this. When pressure increases, volume decreases. So here are the three gas laws equations summarized. I hope you have learned more about the gas laws. In the description there will be a link to some questions of this topic. Please like and share. Thanks for watching.